Hello to all of you. This is Dr. Dhaval Maheta, and today we are going to discuss classification metrics of machine learning algorithms. The performance of machine learning algorithms is evaluated with the help of various metrics. These metrics influence how you weight the importance of different characteristics in the results and your ultimate choice of which algorithm to choose. Various different algorithm evaluation metrics are demonstrated for both classification and regression type machine learning problems. The dataset which we will be using in this tutorial is downloaded from UCI machine learning repository. For classification metrics, the PIMA Indian onset of diabetes dataset is used. This is a binary classification problem where all the input variables are numeric. The target variable is in binary. For regression metrics, the Boston House price dataset is used as a demonstration. It is a regression problem where all the input variables are also numeric. The target variable is numeric. A 10-fold cross-validation test harness is used to demonstrate each metric because this is a most likely scenario you will use when employing different algorithm evaluation metrics. The classification problems are perhaps the most common type of machine learning problems, and there are a range of metrics available and that can be used to evaluate the prediction for these problems. Some of the most popular metrics are confusion metrics, classification accuracy, logarithmic loss, area under the ROC curve, and classification report. First, we will see confusion metrics. A machine learning algorithm can predict 0 or 1, and each prediction is compared with the real data. Predictions for 0 that were actually 0 appear in the cell for prediction is equal to 0 and actual is equal to 0. Whereas predictions for 0 that were actually 1 appear in the cell for the prediction is equal to 0 and actual is equal to 1. Let me represent this by a very small example. Say, for example, we want to test a person is corona positive or not. So a person has a coronavirus and we are using the kit to test it. So if the kit says that a person is positive and in actual also the person is positive, then we will say that it is a true positive. Person with coronavirus tested positive. Now the test results are the person is not COVID positive and test results also confirm the same thing. So it's a true negative. Person without coronavirus tested negative. So the results are we want good results in diagonally means yes and positive should be identified correctly, no and negative should be identified correctly. So green is a correct classification diagonally. Now let us talk about the pink one. Here the person is not COVID positive but the test result shows positive. So this is known as a false positive. Person without the coronavirus tested positive. Here let's talk about this cell. The person is corona positive and the test results give negative. So person with the coronavirus tested negative. Now let us run the same thing in the Jupyter environment. So import pandas. From pandas import read underscore CSV. From sklearn import model selection. From sklearn.linear underscore model import logistic regression. From sklearn.matrix import confusion matrix. We will have to specify the file name where the file is located. Names are the names of the variables. I'll request all my viewers to kindly refer my previous videos to understand the flow of this lecture series. Then we will say array is equal to data frame, which we have specified here, dot values. X is equal to array, colon, means applicable to all the rows, comma, 0 is to 8, columns will be selected. Here, applicable to all rows. Y is equal to array, applicable to all rows, 8th target variable is selected. Test size is 0.33. It means that a training data set will be 0.66. X underscore train, comma, X underscore test, comma, Y underscore train, comma, Y underscore test is equal to model selection train test split. X, which is specified here, Y, which is specified here. Test size is equal to this and the random state is 7. This is a seed which we are specifying. By specifying the seed, we will be in the position to produce the same result again so that we can compare the algorithms. Now we can say model is equal to logistic regression, solver lib linear is used, model dot fit x train from here, y train from here, predicted is equal to model dot predict, and the prediction we have to do on test data set. So x underscore test, matrix is equal to confusion matrix. So y test, the target variable, the original raw data, which will come from here, and the predicted from the model, it will come from here. We want to compare that, how well our algorithm has classified the actual data. Print matrix. As I have already mentioned, you have to see diagonally. 141 plus 51 is a correct classifications. So in total, you can say 200 cases. If you add 141 plus 151, it is 192 cases have been correctly classified. Misclassified cases are 21 plus 41. So 62 are misclassified cases. Now let us proceed ahead. Now there is a matrix which is known as classification accuracy. It's a metric that summarizes the performance of the classification model as a number of correct predictions divided by total number of predictions. It is easy to calculate and intuitive to understand, making it the most common metric used for evaluating the classifier models. So the classification accuracy is number of correct predictions is equal to total number of predictions. Let us see how we can do this in Jupyter Notebook. Import pandas from sklearn, import model underscore selection from sklearn.linear model, import logistic regression. We will specify the file name and we will have to give the path where our database is located. We are using PIMA Indian Diabetes. It is very readily available on UCL repository. Names are specified of the variables. Data frame is equal to read underscore CSV. File name is this file name. Names is the name of the variables. Array is equal to data frame dot values. Now we say x is equal to array colon comma is equal to comma 0 to 8 applicable to all rows. Y is equal to array applicable to all rows 8th column. Then we run kfold. Kfold is equal to model underscore selection dot kfold. Number of splits are 10. Random state is 7. Shuffle, we want to shuffle it and make it true. Model is equal to logistic regression, solver, lib linear. Scoring, we want scoring accuracy, that's a classification accuracy. Results is equal to model underscore selection dot cross validation score. Model will come from this part. X is here, Y here. K-fold, that is a cross validation, is according to the K-fold. Scoring is equal to scoring, which is accuracy which we want. Print. So what we got is 0.77. Now, if you compare 141 plus 151, which is a total, 141 plus 1 plus 51, you will get it 192. Divided by the total number of observations, you will exactly get the same thing. Again repeat, 141 plus 51 is 192. Divided by the total number of the observations will give you this figure. It is known as a classification accuracy. See, accuracy is equal to number of correct predictions divided by the total number of predictions. Now comes the area under the ROC curve. So the area under the ROC curve is a performance matrix for binary classification problem. The AU represents the model's ability to discriminate between positive and negative classes. An area of Z1 represents a model that made all predictions perfectly. It is an idealistic situation. An area of 0.5 represents a model that is as good as random, or we can say that there no model is better. There is no model. ROC can be broken down into sensitivity and specificity. A binary classification problem is really a trade-off between sensitivity and specificity. Now, let us see how we can do this in Jupyter Notebook. Import pandas from sklearn, import model underscore selection from sklearn.linear underscore model, import logistic regression. Again, we specify the file name and the path, names of the variable. Again, we specify data frame is read underscore CSV. Array is equal to data from dot values. X array, Y array, K fold remains the same. Model is equal to logistic regression. Solver is live linear. Now in this scoring, previously we had used the accuracy. Now this time we will be using ROC underscore AOC. Everything else remains the same. 0.826. Quite good. As it is nearer to 1, we can say that the model is working better than the no model. Now there are some other measures of accuracy. First one is sensitivity. Sensitivity is a true positive rate, also called the recall. It is a number of instances from positive class that actually predicted correctly. Specificity is also called the true negative rate. It is a number of instances from the negative class that were actually predicted correctly. Recall is a ratio of correctly predicted actual positive observations. Precision is a ratio of correctly classified positive observations. Let us try to understand. This is a true positive. It means that a person was having a corona and the kit predicted it. A person was not having the corona and the kit also did not predict. Rather, it says that a person is not having the corona. So, true positive and true negative are the desirable results in any machine learning classification problem. The non-desirable, or rather not desirable, is false positive and false negative. On this basis, there are some measures of accuracy which we will have to understand. The overall accuracy is TP plus TN. TP plus TN divided by total number of observations. Fine. This is the first one. The precision is true positive upon true positive plus false positive. This one. So that's it. That is a precision. And the sensitivity is true positive divided by true positive plus false negative. That is a sensitivity. Negative predicted values are true negative upon false negative divided by total negative plus total negative. Now what is a recall? Recall is true positive upon true positive plus false negative. Specificity is true negative upon false positive plus true negative. Now there is an F1 score. So F1 score is a weighted average of precision and recall. Therefore, this score takes both false positive and false negatives into the account. F1 is usually more useful than the classification accuracy, especially if we have an uneven class distribution. It works best if false positive and false negatives have similar cost. Now, which parameter to use, or rather which matrix to use in which situation? Say for example, we are having an even class distribution. It means that the target variable is evenly distributed. Say for example, there are two classes, 1 and 0. We are having an equal observations, more or less equal observations in both the classes. Then we say that there are even classes. And if it is not, then uneven classes. So false negative cost more. If this is a scenario, false negative cost more, we'll be using recall in both the cases. If the cost is same, either you can use accuracy or F1 score or F1 score in uneven. Now, false positive cost is more. Then if it is an even class, we'll be using a precision. If it is an uneven class, we'll be using the precision. So it is only in the case of same cost, you can go for accuracy in even classes or F1 score. Now let us understand what is the difference. What is false negative cost more or false positive cost more? Now here, a person is corona positive. That is yes. And the kit detected it no. So this is more harmful in comparison to a person was not corona positive, not corona. He was not having a corona and the kit detected it positive. So here the weightage is different and therefore we can say that in such scenario, false negative importance is more. So let us see again this. False negative cost is more, and there can be a scenario false positive cost is more. So in the different scenarios, we will have to use different classification metrics. Now the classification report. The SKSet, the scikitlearn library provides a convenience report when working on classification problems to give you a quick idea of the accuracy of the model using a number of measures. The classification report function displays the precision, recall, F1 score, and support for each class. Let's see how we can do this in Jupyter Notebook. Import pandas from sklearn, import model underscore selection from sklearn dot linear underscore model, import logistic regression from sklearn dot matrix, import classification report. We will require classification report. Everything else remains same till here. The only thing which will change here is that now we will say classification underscore report, and we will get the full report of the algorithm. So this is a precision, recall, F1 score, and support. This is for the 0 class. That is for 0 class and the 1 class. Normally, we see accuracy scores only. That is this one, 0.77. But depending upon false positive or false negative, you can check precision also, recall also, and F1 score also. In all these cases, the desirable is 1. The next is logarithmic loss. The logarithmic loss or a log loss is a performance matrix for evaluating the predictions of probabilities of membership to a given class. The scalar probability between 0 and 1 can be seen as a measure of confidence for a prediction by an algorithm. Predictions that are correct or incorrect are rewarded or punished proportionally to the confidence of the prediction. The bottom line is smaller log loss is better, with 0 representing a perfect log loss. How we can do this? Let's see in Jupyter Notebook. Import pandas. Everything else remains same. The only thing is now the scoring mechanism will be negative log loss. And then when we'll run print, what I get, the result is log loss minus 0.494. which is quite nearer to 0, which is considered to be quite good. So this was all about classification matrix. All these codes are given in the book written by Jason Brownlee, Machine Learning Mastery with Python. For more videos on machine learning using Python, kindly subscribe to my channel. You can follow me on LinkedIn and Twitter. Kindly subscribe to my channel and refer my playlist, in which I have already uploaded many videos of machine learning using Python. Please don't forget to press the like button.